This is refractive error of the basics for V551, ocular motility and refraction. Let's review the basic optics of the human eye. The corneal average power is approximately 43.57 diopters, plus or minus 3 diopters. And we have a pupil that can change from dark to light, depending on how bright it is outside. And that affects a little bit of our optics, but the main next optical element is the lens, which has an average power of about 18 diopters, plus or minus 2 diopters. In total, this makes up about 60 diopters of the power of the eye. And this is to put the focus of the light right on the retina. And that's controlled by the distance or the axial length from the lens and the optics to that retina. The average axial length is 24 millimeters plus or minus 2 millimeters. Well, let's look at spherical refractive errors in general. As we talked about, emmetropes, the objective is to put the image focused onto the retina. This allows for the most optimal focus and the best vision. Myopia is when the image is focused in front of the retina. Conversely, hyperopia, or farsightedness, sometimes it's called, is when the image is focused behind the retina. Well, this brings up a point that we have 3 elements, the axial length, the cornea, and the lens, that could all be changed and can induce myopia or hyperopia or emmetropia, depending on the combination of those 3 elements combined. Here we have 3 examples of myopia. First on the left, we have axial myopia. Axial myopia in this case is caused by the eye to be too long or longer than the optics would say is the best focal point. We also have refractive myopia. That could be due to the cornea having a higher power, or it could be due to the lens having a higher power, both increasing in curvature. In these examples here, all 3 result in a 9 diopter myope. The axial myopes, the only difference between their optics, which are totally normal, the lens and the curvature of the cornea, is their axial length is about 3 millimeters more than the average normal person. Refractive myopia from the cornea is caused by the keratometry, or the curvature of the cornea, being higher. In this case, the axial length is normal, the lens power is relatively normal, but the keratometry readings read 53 diopters. And they have a refractive error then of minus 9 diopters. Finally, any change in the lens's curvature that increases it could induce myopia, or if it became less curved and had less power, it would create hyperopia. In this case, the axial length and the keratometry are the same, but the lens has increased its curvature. Again, all 3 of these conditions results in a 9 diopter myope. There, just to illustrate which ones are really different, and everything else is totally within normal ranges. But within that, there are different ways we can get to each class. The most common way to get to a myope is through juvenile myopia, or the traditional myopia you get as a kid. And that results from the eye almost exclusively elongating an axial length. Most myopes and most myopia increases are due to this type of myopia. We could also, though, have changes in the lens power. The lens can become more curved. And that happens in a number of different ways. One way is through diabetes. In diabetes, we have excess sugar in the vitreous and in the aqueous humor. And this can actually penetrate into the lens, causing an osmotic change. That lens swells, inducing myopia, causing the cornea to be the lens to be more curved than normal. We also have another factor called age. As we age, our lens grows in size and becomes more and more curved. Here we have 2 different examples. We have an example looking at 5-year-olds to 96-year-olds and how much more curved the lens becomes, as well as larger and more dense. And there we have a schematic then also of that same event happening, where the lens is becoming bigger over time. Now, as it becomes bigger, if it becomes more curved, it induces more power and can induce myopia. There's also diseases that change the curvature of the cornea. This includes keratoconus, trauma, and corneal disease such as Fuchs. On the left, we have a picture of 2 corneas. One's a normal cornea, and the other one's a keratoconic cornea, where the cornea has become more curved. It also creates a lot of aberrations, which is a major contributor to visual loss. But it's also more curved, which induces higher levels of myopia, and that is due to refractive myopia from changes in the cornea. Thank you.